For question 20, right? In an experiment to determine the percentage composition of calcium carbonate in a eggshell, this quantity of hydrochloric acid was added to 0.400 grams of powdered eggshell. The mixture was then titrated with 0.100 mol per dm³ of sodium hydroxide, which is later found that 20.60 centimeter cube of sodium hydroxide is required, and find the percentage composition of calcium carbonate present in the eggshell. Okay, so for this question, right, first up, you want to identify what are the chemical reactions going on over here, and then we can write a balance equation. So HCl added to powdered eggshell, which contains calcium carbonate. So over here, HCl plus calcium carbonate, which is a solid, gives you a salt, which is calcium chloride, plus CO2 plus water. Right, then we just need to make a comparison, see what are the things to balance out. Okay, so 2Cl, 2H, okay, CO3 seems to be balanced out also. Okay, so this is good and well done. Alright, then afterwards we need to go sodium hydroxide reacted with and HCl. So HCl plus NaOH equals, and this gives you NaCl equals plus water, and there's no need to balance it because it's already balanced. Okay, afterwards you want to determine what is the excess and the limiting reagents for this reaction. Okay, so for the first reaction you realize that okay, they did not seem to specify, but the fact that they did not seem to specify very clearly over here what is the limiting reagent or excess reagent based on the question. Okay, so in this case, but then you look at the second question, they say when it was titrated with 0.100 mol per dm³ of sodium hydroxide, it was required that 20.60 cm³ of sodium hydroxide is required. So whenever a titration reaction is going on, you can definitely assume this is a complete reaction. So there is no excess or limiting reagent over here. Okay. And the fact that it's titrated, this mixture is titrated, it means that it could suggest that this mixture contains unreacted HCl. Okay, the fact that it contains unreacted HCl means that the hydrochloric acid should be in excess. Okay, so even though the question did not state clearly excess or limiting, this is how you can infer, right? So over here I can put on the header over here, this should be in excess, this should be limiting, right? Just a fun fact, usually when we are talking about impure substances like CaCO3, usually you are recommended to add an excess of the other reagent into the reagent that is impure, so that I can form out all the calcium ions and all the basically form out all the calcium ions that I have needed. Okay, so to completely remove calcium carbonate so that I have the unreacted HCl to react for titration. Okay, then after I determine that, I can apply the mole ratios. Okay, maybe for a fact we can actually write some of the information that we are given here. So the volume of HCl, and this will be the total volume. Okay, I can actually write this in terms of number of moles. Okay, so number of moles you can determine is 10 over 1000 times 1.0. Okay, 10 over 1000 times 1.0, it will be 0.01 mole, right? So this is done. Okay, the fact this powdered eggshell is impure, if it's impure, I should not use this value yet, okay, because it's impure. Afterwards, another data we receive is, okay, we have the concentration of NaOH. Okay, we also have the volume of NaOH given to be 20.60 cm cube. So it's 0.100. And in this way, I can calculate for the number of moles of NaOH fully reacted. So this will have been 0.002060 mole, right? And because I know the number of moles of NaOH reacted is 0.002060 moles, I want to find out, okay, so at the end of the day, I want to find out the percentage composition of CaCO3. If I want to find out what is the percentage composition of CaCO3, so this percentage composition will have equal to the mass of CaCO3 over the mass of powdered eggshell. Times 100%. And I know that the mass of powdered eggshell given is 0.400 grams. So this is 0.400 grams, okay? And now I need to know what is the mass of CaCO3. If I want to know what's the mass of CaCO3, I need to find out what is the number of moles of CaCO3. If I want to know what is the number of moles of CaCO3 reacted, I will need to know what is the number of moles of HCl reacted. Because if I want to find out what is the number of moles of these other things reacted, the thing is that there's no relevant data to find out the number of moles of these other reactants over here. So I need to find out the number of moles of HCl reacted in reaction 1. Okay, but how do you find that? The thing is that you are given the total number of moles of HCl. Okay, so the only way to find out what is the number of moles of HCl reacted is if you take the number of moles in total minus off the number of moles unreacted. Okay, and how you find out what is the number of moles of unreacted HCl? You have to go back to reaction 2, because in reaction 2 the mixture was then titrated, so this means that the unreacted HCl is used to react with NaOH. So the number of moles of reacted NaOH over here is precisely the number of moles of HCl reacted in reaction 2, which is 0.002060 mole. Okay, and then when you look back at the question, you realize that this is actually also the same as the number of moles of HCl unreacted in reaction 1. Okay, so this is 0.002060 mole. Okay, and then when you want to put these numbers here, so 0.002060, and this one will be 0.01,000, right? You get a value of 0.007940 moles over here. Okay, and then when you want to calculate for the number of moles of CaCO3 reacted and make use of mole ratios, so 0.007940, okay, divided by 2, so times half, because 2 is to 1, right? 2 is to 1. Okay, zero point 0.00397 mole. And then when you want to get the number of moles of CaCO3, okay, so maybe I shift this a bit. Okay, you just need to multiply by the molar mass. Okay, 0.003970 multiply by 100.1 because that is the molar mass. Okay, 0.0, so this one times 100.1, this gives you 0.3973 grams. Okay, don't round off, right? And because this is 0.3973 and it's 0.400, okay, you multiply this by 100, you get 99.3%. Okay, and this will be your final answer. So maybe, yeah, so you should definitely write whatever you know first, the things that you know first in the left hand corner. So you can see over here this things. Okay, this is what you know, right? And then the calculation may be on the right hand side. Okay, and sometimes if you do not know where you're going, try to work backwards like what I have done over here. So from percentage composition, what information I need, and from mass of calcium carbonate, how do I apply formulas to go back, and maybe okay, apply other formulas and concepts like mole ratios to know that I need to find the number of moles of hydrochloric acid reacted. Okay, and that should be it.